So here we're going to calculate the effective nuclear charge in a 4s electron in potassium. So we know that effective nuclear charge equals the nuclear charge minus the shielding. We can get the nuclear charge from the atomic number of potassium, 19. And so now we just need to calculate the shielding. So in order to do that, we'll follow the instructions on the right. And so we'll start with writing out the electron configuration, but we're going to write it out in a special way. So we're going to go by n quantum number, and we're going to put things together in these little groups. So that the p and the s electrons are together. And so after 3s and 3p, I'm actually going to write 3d, even though there are 0 electrons in the 3d shell, because it comes next in the quantum numbers. And then the same, I'm going to write 4s1, 4p, 0, because the s and the p go together in a little group that we'll see in the next step. Okay, so then the steps say, electrons in groups to the right or higher don't shield. We're interested in the valence electron, so that's not super relevant here, but it will matter. And then for ns and np, electrons in the same ns-np contribute 0.35 to shielding. So shielding is going to be 0.35 times the number of other electrons in the same ns-np parentheses. So that's why we wrote the s and p together. So in this case, there are 0 other electrons. So electron does not shield itself. So there are 0 additional electrons. And then we go down to the n-1 level. So that would be all of the 3s. And those shield by 0.85. So that's 8 in the 3s, 3p group, and then 0 in the 3d group. And then all electrons below that then shield 1. So that'll be 10 electrons. Okay, so if we add all of that together, we get 16.8 for our value of S. All right, so then to calculate Z star, we take 19 minus 16.8 equals 2.2. So that valence electron in the 4s orbital only feels 2.2 units approximately of the nuclear charge, even though there's 19 protons in the nucleus.